The two air conditioning packs operate automatically and independently of each other. Let's follow the flow of bleed air as it enters and flows through a single pack. First, when the pack is on, the warm, preconditioned bleed air enters the cooling path via the pack flow control valve and is ducted to the primary heat exchanger, which provides the initial cooling of the air. Each pack flow control valve is pneumatically operated and electrically controlled. The pack flow control valve regulates the flow of compressed air to the pack in accordance with signals received from the pack controller. It is turned on when the pack push button is selected on and turned off when the push button is selected off. If there is insufficient air pressure, a spring keeps the valve closed regardless of the switch position. Even with the pack push button selected on, the pack controller will close the pack flow control valve if the pack overheats, if the fire push button of the associated engine is pressed, or if the ditching switch is selected on. The pack push button normally remains in the on position. During engine start, the pack flow control valves will automatically close as soon as the mode selector is set to IGN or CRK for start. During engine start, the pack flow control valves remain closed when the master switch is set to on, or the man start push button is set to on, and the start valve is open and N2 is less than 50%. After engine start, the pack flow control valves automatically open. However, on the ground, reopening of the valves is delayed for 30 seconds after the first engine start. This delay avoids cycling of the valves before the second engine start. If the second engine is not started within 30 seconds, the pack flow control valves will open until the second engine master switch is set to on. The operation of the pack flow control valve is displayed on the ECAM bleed page. The amount of flow that is provided by the pack flow control valve is also displayed. When the valve is closed, the flow indicates on the low side and is amber. At other times, the flow line displays in green and to the right of the low position. Read the pop-up information about this display. The cooling air over the pack heat exchangers is provided by a pack-driven cooling fan, and in flight, cooling air is also provided by ram air. The cooled bleed air enters the compressor section of the air cycle machine and is compressed to a higher pressure and temperature. The temperature of the air that exits the compressor section is displayed above the pack flow. It normally displays green, but displays amber for temperatures over 230 degrees centigrade. After passing through the compressor, the air flows through the main heat exchanger, where it is cooled again. A water separator system dries the air before it enters the turbine section. After the main heat exchanger, the air flows through the turbine section where it expands and heat is removed from the air. This expansion generates power to drive the compressor and cooling air fan. The removal of heat energy during this process reduces the temperature of the air, resulting in very low air temperature at turbine discharge. Let's go back and discuss the anti-ice valve. This valve automatically opens when icing conditions are sensed at the output of the turbine section. The purpose of this valve is to allow warm air to bypass the cooling process and stop the formation of ice. It can provide a backup method of temperature control in abnormal conditions. More on that later. A bypass valve is also installed. It is automatically modulated by the pack controller to provide control of the output temperature of the air from this pack. Without the operation of the bypass valve, the pack would always provide the coldest possible output. With the operation of the bypass valve, the output temperature of air from each pack can be controlled. The position of the bypass valve is displayed on the bleed page and automatically modulates between C, cold valve closed, and H, hot valve open. Read the pop-up information about this display. The temperature output from the pack is also displayed on the bleed page. The display is normally green, but becomes amber if the temperature exceeds 90 degrees centigrade. Read the pop-up information about this display. Okay, we have described the operation and displays for the packs. Now we'll describe the operation of the temperature control for each zone. The hot air pressure regulating valve controls and regulates the pressure of hot air tapped upstream of the packs that is delivered to the trim air valves. The operation of the hot air pressure regulating valve is displayed on the ECAM condition page. Read the pop-up information about this display. It is pneumatically operated and electrically controlled from the hot air push button on the air condition panel. This push button normally remains on for automatic operation of trim air. In the absence of air, a spring keeps the hot air pressure regulating valve closed. With the hot air pressure regulating valve open, the individual trim air valves can optimize the temperature of each zone. In abnormal conditions, the hot air pressure regulating valve closes automatically if the duct overheats, or the cockpit trim air valve fails, or both cabin trim air valves fail. Note: the hot air pressure regulating valve remains operative even if either the forward or aft cabin trim air valve fails, but not both. The trim air valves are electrically controlled by the zone controller. One trim air valve associated with a specific zone adjusts the temperature by adding hot air to the air from the mixing unit according to the selected temperature of the zone temperature selector. The operation of the trim air valves is displayed on the ECAM condition page. Read the pop-up information about these displays. Automatic temperature and flow regulation is controlled by one zone controller and two pack controllers. We'll first describe the operation of the pack controllers. Each pack controller regulates the temperature of its associated pack in accordance with the demand signal from the zone controller by modulating the bypass valve and the ram air inlet flap. The pack controllers also regulate flow by modulating the associated pack flow control valve. Although you have learned that the ram air inlet flaps are normally modulated for temperature control, they close during takeoff and landing to avoid ingestion of foreign matter. During takeoff, the ram air inlet flaps close when takeoff power is set and the main landing gear struts are compressed. During landing, they close as soon as the main landing gear struts are compressed as long as speed is at or above 70 knots. They open 20 seconds after the speed drops below 70 knots. The flight crew uses the zone temperature selectors on the air conditioning panel in the cockpit to select the reference temperatures. With the zone temperature selector at the 12 o'clock position, the approximate selection equals 24 degrees centigrade. The full cold position represents an approximate setting of 18 degrees centigrade, while the full hot position represents an approximate setting of 30 degrees centigrade. The zone controller computes a temperature demand from the selected temperature and the sensed actual temperature. The actual temperature is measured by sensors located in the cockpit for the cockpit zone or in the lavatory extraction circuit and galley ventilation system for the cabin. The temperature of each zone is displayed in green on the ECAM condition page. The temperature of the air in the duct to the zone is also displayed. The duct temperature normally displays in green, but displays amber at 80 degrees centigrade or above. A signal corresponding to the lowest demanded zone temperature goes to the pack controller, which then makes both packs produce the required outlet temperature. As you know, the zone controller optimizes the temperature by action of the trim air valves. The temperature selection range is from 18 degrees centigrade to 30 degrees centigrade. The crew can use the pack flow selector to adjust the pack flow for the number of passengers and for external conditions. There are 3 positions for this selector. Low equals 80%, norm equals 100%, and high equals 120% of flow. Low flow might be selected when there are light passenger loads below 115 and minimal need for temperature change in the cabin. This mode demands less bleed air and therefore increases fuel efficiency. Note: the system delivers normal flow if the crew selects low flow and the temperature demand cannot be satisfied. Norm is selected to provide the normal flow rates. High flow should be selected when there is hot and humid conditions. Regardless of the selected flow rate, the system delivers high flow when in single pack operation or when the APU is supplying bleed air. The engine and APU bleed outputs can be automatically increased when the packs provide insufficient cooling. When the APU bleed valve is not open, and the cooling demand in one zone cannot be satisfied because the engine bleed pressure is too low, the zone controller sends a pressure demand signal to both engine interface units, EIU, to increase the minimum idle and to raise the bleed pressure. When the APU bleed valve is open and any zone temperature demand cannot be satisfied, the zone controller signals the APU's electronic control box, ECB, to increase the APU flow output. On this frame, you can move your mouse over each switch and light and view a pop-up description of each item. This completes the description of normal operation of the packs and zone temperature control. Now let's answer some questions.